Okay, here's a question fragment from a Core 3 paper. In fact, the lettering this was part B, part A's been taken out, and this was part C, so that will help me when you get to references to part B. Given that y equals inverse sine of 2x, we've got to make x the subject of that formula. So the way that's going to work is you're going to start with y equals inverse sine excuse me, of 2x. On the next line you're going to have something equals 2x, and on the last line you're going to have something equals x, and you know what that something is. Be convincing. In b.e2 we've got x in terms of y, and we've got to get dx by dy in terms of y. So this is just ordinary differentiation. You don't need any fancy rules, that's why it's only 1 mark. But x is an easy subject of y rather than y being a function of x. You just apply the normal rule for differentiating a sign, and of course the answer is dx by dy, not dy by dx. Then comes the slightly clever bit, but it leads you through it. It says we want dy by dx, and we've got to arrive at this. Well, we've got dx by dy already, so therefore, in order to get dy by dx, we just need to turn it upside down, do its reciprocal, do 1 over the previous answer. We've got to use a suitable trigonometrical identity. We're dealing with trig functions, and we can recognise 1 minus something being squared over here. What's okay in all show that questions is writing the answer you're aiming for at the bottom of the page, and writing your starting point, which is what dy by dx is from turning this upside down at the top of the page, so you'll have a fraction there, and then working from both ends towards the middle. So we need to fill in this gap. Now one way to get started would be to start with the destination, on the line above write 2 over the square root of 1 minus 4x squared, but for your x go back to what x equals, and that should help you realise exactly what's going on in terms of the trigonometrical identity you need and how to make the two beginning and end points of this match up. Good luck with that.